is our second video on percents. This is our part 2. Okay, we're going to look at some percent increase and decrease examples. We're going to look at some application examples, and we're going to work at explaining our reasoning. So let's first look at this. The first thing we want to look at is percent equation or proportions. Now, I actually like to do these kinds of problems as a proportion. And my general rule of thumb for thinking about this is to think of my part out of the whole is equal to my percent out of 100. Okay? Part out of the whole is equal to the percent out of 100. Now, the percent is really easy to find because it's typically labeled in the problem or they tell you it's the thing that you're looking for. 100 makes sense because if I'm thinking of parts out of wholes, percentages are parts out of 100. So this right side of the proportion will be consistent in the way it's set up. Now the left side, I like to think of these values when I look at these kinds of word problems as this is my is number and this is my of number. Okay, and this is kind of a general rule of thumb. You want to think about what is the total amount you're looking at. Okay, so when we look at this first question, it says the state sales tax is 7 3/4%. So first off, 3/4 is equal to 75 hundredths or 0.75. So if I have sales tax that's equal to 7 3/4%, that's going to be 7.75%. So written as a decimal, that's going to be 0.075. Okay, so that is my sales tax. But I can actually use this in this percent equation or this percent proportion as the percentage because this conversion happens automatically in the setup. Okay, so if you use this method to solve and setting up the proportion, then you will not need necessarily to change your percentages to a decimal. Okay, so that's like a nice little fun fact. Okay, but let's set up our proportion and then solve it. So we know in this problem, for number 1, that my percentage is 7.75% out of the total 100%, which is equal to the part or the sales tax out of the total purchase price. Or do you see that of 85? So that is our of value, $85. And what's missing is our tax. Okay, so once we have this, we can solve our proportion using a method that you might have recalled or seen before, and we can use cross multiplying to solve this. So in order to cross multiply, we take the diagonal values. So this would be 100 times t equals 85 times 7.75. $85 times 7.75 is 658.75, which equals 100t. To solve for t, or the amount of tax, we would divide both sides by 100. And so t, it's going off the page, t equals 6.5875. You'd want to round that to the nearest cents because we can't cut pennies up into pieces. And so that would end up being rounding to the hundredths place. This would round it up. So that's going to be $6.59. Okay, let's do a few more of these. I'm going to duplicate the page, but not the ink. Let's do number 3. So remember, we have our part, which is our is number. Our of number is equal to our percent out of 100. So we want to identify what pieces of information we have. We always start off with the 100. We know we have that. Okay, and we're going to read the question. It says 1,190 miles is 140% of what number of miles? So look here, we have our percentage, so we can put that in its place. Okay, we have that over 100. Now let's look of what number of miles. This is our unknown. Of what number? So our of value is our unknown. So I'm going to label that as M for miles. And 1,190 miles is our is number. Now the is number is kind of tricky because sometimes it comes first, like 3 is, or it might come last, like is 3. And so that's the number I always figure out last. Okay? I look for my percent, I look for my of, and then I look for my is. Does that make sense? Essentially what I'm saying is I look for the percent first, and then the total number next, and then the part last. Okay? So then we solve this using cross multiplication. I can post a video as to why that works. If you're curious, just let me know. But here I'm going to multiply my diagonals by each other. So we get 140m equals 1,190 times 100. That's going to be 119000. Just adds 2 zeros on the end. So 119,000 equals 140m. To solve for m, we divide both sides by 140. So therefore, when we do that, I'm going to write the answer in red on the left, and that gives us 850. Now, our part is bigger than our whole. Do you see that? Our part was 1,190, but our whole was 850. But that should make sense because our part, our percentage, is bigger than 100. So our part is bigger than our whole. Okay, let's try one more. Let's do number 9. Janelle had budgeted $250 for textbooks. She ended up spending $390. The amount spent was what percent of her budget? So the whole that she wanted to spend, this one's tricky because they don't straight up say is and of. Okay, but we do know that we start out of 100. What's missing is what percent. So my percent is what we don't know. And then we know that her budget was 250, so that's going to be her whole. So that's 250, but what she actually spent is her part. So the percentage that she spent is actually going to be greater than the 100% she wanted to spend. So to solve this, we end up using cross multiplication. We get 250 times P equals 390 times 100. That's going to be 39000, so 39,000 equals 250 times P. To solve for P, we divide both sides by 250. And we end up getting that our percent is equal to 156%. Again, if you need to see more of these, you can look at the Pearson videos that are posted, or you can also email me and we can work out more examples. Now the next thing we want to look at is percent change. When we have percent changes, what ends up happening is we take our new value, we subtract our old value or our original value, and then we divide that amount or that difference by the original old value. Okay, so you could also think of this as if we end up getting a positive number in the top, that's going to show us a percent increase. If we end up getting a negative number in the top, that's going to show us a percent decrease. Okay, because if our new value is less than the old value, then when we subtract them, we'll get a negative number. Then we divide by the old value, we'll still have a negative number because a negative divided by a positive is a negative. So if we end up with a negative, that indicates a decrease. If we end up with a positive, it indicates an increase. So let's look at two of these examples. First off, we have in England, the base cost of a loaf of bread is £4, but the listed price after tax is £4.72. What is the tax rate? Okay, so we want to say our part is the £4. The whole is the £4.72, or this we could think of as the old, and this is the new with tax. So to solve this, we're going to do 4.72 minus 4 all over the old value, 4. Okay, so we end up getting 0.72 divided by 4, which is equal to 0.18, or that would be 18%. So now we're going the opposite and going from a decimal to a percentage. When we go from a decimal to a percent, instead of dividing by 100, we do the opposite, which is multiplying by 100. This is a percent increase because the amount with tax is greater than the original amount pre-tax. Okay, let's look at number 14. According to the Texas Tribune, in 2012, the annual cost of an education at the University of Texas was $9,794. That's tuition and fees. According to UT Watch, the 2001 to 2002 average tuition and fees was $4,226. What was the percent increase over the decade? So we already know it's a percent increase because the new value is much greater than the old value. But when we think about this, we want to talk about the part, which was the original, 4,226, and I like to call that old. And the whole value, or the new value, is 9,794. And when we solve this, we're going to take the new, subtract the old over the old. So I'm going to do the numerator first and do that subtraction. And when you do that, you might want to put that in parentheses in your calculator, because if you just type out 9,794 minus 4,226 divided by 4,226, and you don't put the top in parentheses, you're going to have a problem because it's going to follow the order of operations. So it's going to do your division first before the subtraction, but the order that we need to do this, and that's because this is a vinculum and this actually groups our top together, is we need to do that subtraction first. So 9,794 minus 4,226 is equal to 5,568 divided by that 4,226. I like to do it in pieces, but that's up to you. If you want to put it all in together, you just got to make sure that you put the top in parentheses. And our final result is a 1.31755, and it keeps going on. Okay, what we're going to do is we're going to turn that into a percentage because it's a decimal. So we multiply this by 100, which moves the decimal 2 places to the right. So that's a 131.8% increase. That is wild. It won't let me finish off that percent sign, so we're going to move on. Okay, let's look at some more examples. Suppose that 30% of the female students and 40% of the male students in a college history class are from a major city. If there are 50 female students, how many females are from a major city? This kind of question, I would go back to that 10% rule. I would say, what's 10% of 50? Well, 10% of 50 is 5. So 30% is 3 times bigger. So that's going to be 15. Okay, so 15 of the female students are from a major city. If there are 30 male students, how many males are from a major city. So we're trying to find 40% of 30. So again, I'm going to take 10% first. 10% of 30 is equal to 3. So 40%, which is 4 times bigger than 10, will be 4 times bigger than this result. So that's going to be 12, because 3 times 4 is 12. So how many students are there in total? Well, there are 50 female students and 30 male students, so 50 plus 30 is 80. And what percentage of the class is from a major city? Well, I would add up the female students plus the male students who are from a major city, and then divide it by the total number of students. That will give me a decimal answer, so I get 27 divided by 80, and we get 0.3375. And so we're going to say that changing that to a percentage, we just multiply it by 100, which would give us 33.75% of the students are from a major city. Now we're going to look at the same example with different numbers. So now we're going to have 30% of the female students and 40% of the male students in a college government class are from a major city, but there are 50 female students, which we had before. We already found out that 30% of 50 was 15. That's the same, okay? And if there are 50 male students and we find 40% of 50, we can use our 10% rule, or there's other ways we could do it, but let's do the 10% rule. 10% of 50 is equal to 5. So therefore, this is 4 times bigger, so I need to multiply this by 4, so that's equal to 20. Okay? So then we figure out how many students are there in total. Well, 50 plus 50 is 100, because there are 50 female and 50 male, so there's 100. And so what percentage of the class is from a major city? Well, I'm going to do 15 plus 20, so all the students who are from major cities, divided by 100, which equals 35 out of 100, which is 35%. Now, if I do 35 divided by 100, I'm going to end up getting 0.35, and then multiplying that by 100, we get 35%. Okay, so I kind of skipped a step in there because I noticed that this was already out of 100. So in these two situations, I can only find the total percent by adding the percentages together if the total number of people equals 100. Okay, it didn't work for the other class because the other class, the first history class, only had 80 students. So your part out of your whole was a part out of 80. So you had to actually determine what that would be if it were to be a percentage out of 100. Okay? The process that we used to solve that first problem, we could have also set this up as a proportion. We could have said 27 out of 80 equals what percent out of 100, and we could have solved that, and I can write this as a p instead of percent. We could solve that using that proportion that we saw earlier. Okay, so multiply 80 times p will be equal to 27 times 100, and then solve for p. Okay, either way, you're going to get the same result. This one was super nice though because the total number of students already added up to 100. So however many were from a major city, we're already out of 100. That goes directly to a percentage because our total was out of 100. So our problems are not always going to be that nice, but we hope that they are. Okay, so the first one worked, or the second one worked for the government class because the total equaled 100. So tot equals 100. This one, it didn't work for the other class because the total did not equal 100. Let's look at this next example. We have a shoe store marks up the price of its shoes at 140% over cost. A pair of shoes goes on sale for 15% off. It got cut off, but that should say 15% off. And then on the clearance rack for an additional 35% off. So what is the price after the markup? Okay, so we have the cost of the shoes. We're going to call that C. And to find out the cost or the price after the markup, we have to multiply that by 140%. And we can write that as 1.4 times C, because I can rewrite this as a decimal. So in general, without specific numbers, we have that the cost of the the cost of the shoes or the price of the shoes after the markup will be 1.4 the cost of the shoes that the store gets it for. Okay? What is the price after the 15% discount? Well, we would take 0.15 times the 1.4C. But I want to be clear that this represents the discount, not the cost. Okay? So that represents the discount. 15% of the 140% cost, that gives us the discount that gets taken off. So to actually figure out our value, we need to take the cost of the shoes, or the price of the shoes, and then subtract this discount. Okay? So when we do 0.15 or 15% of 1.4C, that gives us 1.4C minus 0.21C, which equals 1.19C. So we are actually representing the cost or the price of the shoes as a function, because it depends on what the original cost of the shoes are based on the pair of shoes. So if our shoes, like let's say the store buys a pair of shoes for $10, okay? So then they sell the shoes for $14 because that's 140% of what the original cost was. I would get that by doing 10 times 1.4, which gives us 14. Then if they wanted to take off this discount, I would take 21%, or I could just do 10 times 1.19 because we've already done the algebraic work to show what the cost should be with that discount. So in that case, our cost of our shoes, or our price of our shoes, would be $11.90. Okay, so with that discount, that shoe store is still making some money. But once it goes into that clearance rack for an additional 35% off, they're going to lose money on those shoes that they're selling. Okay, so, but that 35% would come off of this value here. Okay, so we'd follow the same process we did for B, but we would start with the 1.19C minus 0.35 times 1.19C to get our final result. Okay, I know this is kind of abstract, but you could do an example with real numbers and like pick a value for the cost of the shoes and figure out what happens to that amount. Okay, so I'm going to skip this one. We're going to look at, let's think about this one right here, number 8. Again, we're talking about things happening in general. So let's say a stock index decreases by 10% in one day. So we have the stock decreasing by 10% of its original in one day. So that ends up being 0.9 times the stock index. But then it increases 7% by the next day. So we're going to take our starting value for the next day as 0.9 times S. And then to that, we're going to add 0.07 times 0.9S. And when we combine, we'll multiply these terms together. That's an S, not a 5. When we combine or multiply these terms together and then add them to our original starting value, we end up getting that at the end of the second day, we have 0.963 times our stock index. Okay, so can we just say that there's a total decrease of 3%? No, the actual decrease from the original amount to the end of the second day is actually a 3.7% decrease. And that's because this 7% doesn't apply to the original value, it applies to the new value. Okay, so going through that same concept, you can try the next few examples on your own. And then if you have any questions, please make sure you email me and let me know. I don't want to make this like a 3-hour-long video going through all of these, but if you do need help, please reach out and let me know. This should be enough for you to get through the 10.1 homework with percentages, but again, if you need help, don't hesitate to email me.